What we would like to do is perform a sensitivity analysis on the model. And when I mean sensitivity analysis, is regardless of whatever model that we are using. In this case, we are illustrating the example with a numerical simulation model that actually takes 20 minutes to run. We would like to alter, to change some of the input variables or input values. In this case, we would like to have a look at the effect of conductivity in the model, and see what is really affecting the objective function, the objective function or the history matching quality on the model. So we would like to also understand at some point whether the inputs, whether what we are changing, it's important or it's something that is negligible, at least for the history matching. And categorize those as influential or least influential history matching, let's say, properties. And in order to do that, so yes, we have our reference case, which we are going to use to calculate our objective function. We have our, we're going to go into in a bit into the details of a model and determine what things we can change and perform a sensitivity analysis. And then we're going to use an experimental design technique to execute the sensitivity analysis. We're going to run quite a few simulation cases, or at least I'm going to provide the simulation cases that I have run already, but I'll show you how I have run them in Python. And at the end, well, we would like to get some sort of performance chart. So in a kind of a full stack workflow of sensitivity and uncertainty analysis, what we are trying to do is this upfront part where we characterize what is driving the history matching quality of a model, and understanding in the great scheme of things, what is the connectivity, what are the key drivers of connectivity in the model. So now going into the details of a model and what we're going to do in terms of a sensitivity. So there are quite a few faults in the model. And actually, let me create a new view here so to show you the large number of faults that are available here or that are present in the model. Let me see, where is it? Here. So there are quite a few faults, and some of those faults are split into different segments. And you can see the distribution of the different faults. And let me actually put it at the end. And what you see in the fault section, it's the water, the oil saturation associated to the cell next to the fault. And you see also the different wells that are draining or injecting into the reservoir model. Now, I don't want to use all those faults because really it's a lot, and I kind of took some of those faults that could drive the connectivity across the main wells, and you could see some of the faults here. So all of them, if you click on on Res Insight, you can see the name of the faults here at the bottom. So those are the faults that I'm going to be, let's say, a performance sensitivity analysis on those faults. The other part of a model that we would like to evaluate, it's the connectivity between these different zones here at the bottom of the model. So we want to see how a change in the connectivity, let's say this is there is no clear barrier between these different zones. And we would like to see how the connectivity between those two zones drive the history matching quality. Any questions, comments so far?
Alejandro,
Yeah.
This is Victor.
Hey,
Um,
Victor. Yeah.
hi. Very nice talk, very nice functionality of the open source simulator. My question is, how flexible is this simulator to, for instance, to set some local seals in order to get a better match in, especially when you have a water dry movement system and you need to place these features, this geological feature, in order to honor the heterogeneities of the geological model. How
Yeah.
flexible is this simulator to do this?
Well, you will see in the sensitivity analysis, because that's exactly what we're going to do now. We're going to add, we are going to modify some of the connectivity within the model. Again,
Okay.
so the two things that we're going to do is sort of a structural connectivity. I have picked quite a few faults, and as you know, there is you have the fault definition in Eclipse and the multi-FLT keyword in Eclipse that modify the transmissibility between adjacent cells. These are the ones that I have picked, and the other is a high-level stratigraphical connectivity between the different layers. So those are the kind of two things, and I'll show you. Let's go directly into the file. And if we go into the file, and this is the original file that I downloaded, that I showed previously. So there is this equals keyword. So you can use the same, pretty much the same keywords that you will use in Eclipse, like equals to modify the pore volume or modify permeabilities. So what we're going to do here is modify the multiset for the main features or the main connectivity between these two zones, and these two zones. And the other thing that we're going to do, it's I tried to do this, but that it's a bit. It was going to be a big problem to perform for just one session, and it will require probably hundreds of simulations to perform a big sensitivity analysis. So I constrained the sensitivity analysis to 20 variables that I'll show you in a bit. And actually, I'm going to do it live. So for these variables here, what I'm going to do is, let's assume that we don't know anything about the connectivity between these two zones. And there is a special character that I'm going to introduce here. As you know, if you're working with MIPO, I think they have the __ variable __ format. If you're working with Petrel, you have the $, format. Yeah. And because I don't want to have issues of copyright, I'm going to put hash. And please let me know if there is someone using hash. I can change it to something else, and we can go along. So let's say we want to see the multiset of EE connectivity, and we want to see also the multiset of the hill connectivity. I'm going to start to replace some of these numbers here, so I can play with the connectivity between those zones and understand what is really driving the connectivity, or what's really driving the water cut evolution in the wells, and that could help me do a better characterization, better modification of a simulation model. So, and then I'm going to do multiset ilg here. So I have those three variables. There is another file, which is this one. It's a false one. So if I show you, there are two files for false. This one is the actual fault definition. So if I go into the include, and if I go into the fault folder, let me open these two files. So this is the actual fault definition. And in here you have the actual transmissibility multiplier. There is a question here. How do you store keywords for fast access like this? I don't understand the question. We'll see. We'll see. I'll show you in a bit how I'm going to replace the keywords and how I'm going to detect the keywords. There might be better ways to do it. I'm just going to show you one of the ways in which I have managed to do it in the past, and you can do other things. I'm pretty sure. But here you go. You have the transmissibility multiplier for those faults, and some of those faults have pretty much.
I asked about the type of text editor you use. I mean, you wrote simple. You wrote 2 or 1 letters, and you auto completed the keyword.
I'm using Notepad++, which is as well open source, and you can use UltraEdit. I like UltraEdit a lot, and I think it's worth whatever the price is at the moment. I think it's $100 or depends.
Is it compatible for auto completion for OPM keywords?
Well, it works. I'm not quite sure what you refer with auto completion, but it's a text editor. It's pretty much a flat file and you can replace the values. So remember that the simulator is compiling the text file, which is an ASCII file, reading through the file, and interpreting everything that is in there. So these keywords are just there for the simulator to consume.
Thank you.
So one thing that I'm going to do is I'm going to take some of these transmissibilities out of this file with the permission of Statoil. I'm going to put them in here. I'm going to replace this file in here. And what I want is to put some, as I mentioned, put some sensitivity or parameterize the file in a way that I can put some variables to this, all these faults. So I want to see what's really driving connectivity around in the greater scheme of things, right? Now, this file, I know all the files. I have a solution here. I'm just gonna copy and paste, but that's just following more or less the sequence of steps so you understand what I have done previously. So here you go. You have the modified file, and instead of having the value of a transmissibility multiplier, I'm going to have a variable that defines that transmissibility multiplier, so I can generate new files and run the file subsequently. And I'm going to save this file as my parameterized file. Sorry, we haven't gone into Python yet. We're going to go there in a bit. Actually, there is something, let me, this needs to be a farm. Okay. There you go. Now I have all those variables, and I want to be able to detect those variables, replace those values with whatever value we want to run. So let's start now with the next part. And let me double check here my script. And yeah, just a reminder of what we want to achieve. Yeah. So we have, this is one of the wells, I believe. I'm not quite sure which well is it. I think that we will go in a bit into the details of those wells. But you can see that in the black points this is an oil production rate, this is a gas production rate, water cut, and the bottom hole pressure. And every one of those lines in colors is a different simulation models that I have previously generated, and we're going to go into the details of those. The black dots are the observed data, or at least the reference data for the simulation model. And ideally, we should be able to get to a match on those areas. And as you can see, we have data for the oil production rate, and we have data for the water production rate or the water cut, but we don't have data for the bottom hole pressure. We don't have observed data. There is a question here, how are these variables assigned to the file? Is that randomly done here? No, we'll go there in a bit. So that's where we will cover, that's what we will cover in experimental design. Right, so far so good. Now I'm going to create my first file, my first simulation file, or sorry, my first Jupyter file to execute a project, the process of replacing those variables. Okay, so let me open a Jupyter notebook. So GQ is asking, can you change the whole relative permeability table instead of just changing one variable? Yes, you can have, let's say you can generate different relative permeability curves and replace, put a whole variable to the whole, for the whole relative permeability, Yes, you can do that. So if you want to do sensitivities on the Cori exponent, you can have different files with different Cori exponents. However, remember that now you have the power of Python. And one thing that you may want to do is generate files on the fly. So if you code your Cori exponents in Python and you generate relative permeabilities, you can generate those relative permeability files on the fly and make sure that those are available in your include files as you're generating new variables. And I show you in a bit how you can do it. So the first thing that we're going to do is let's detect all there are few words that I use interchangeable, and I use the word features or variables or input variables, also independent variables, interchangeable. So, and mainly referring that those are the variables that we are changing to alter the simulation model. So we're going to detect those. And for that, we would like to read the file. Let me see. Right. So for that, I would like to read the file. So the file is inside OPM data, norm, and there we have it. We have norm, and I believe we have norm ATW param. So if you're asking yourself how I'm doing to autocomplete, I can just click on tab and it just shows me all the files that similar to what you will have in Linux. There is a question here. For matching, do we consider to remove the outliers or do some of data normalization? Do we achieve good match with machine learning? You will see that. So remember that when you're using experimental design, you don't have outliers because you are controlling your samples. That's a key difference here. When you're driving, when you're doing sensitivity analysis on a model that let's say that you're creating a synthetic reality and you are simulating that synthetic reality, you have the possibility to change the model in whatever way you want. So we're going to create samples on that synthetic reality. And for that, there won't be outliers. I won't be putting outliers on the model. So there is no such thing as data normalization. There is something that we need to do in terms of, and I'll show you for the scaling of the connectivity. And that's more a domain, RESO engineering domain edit. Okay, so we have a file that we want to, and I want to store all the variables. And let me add here a counter. Just please bear with me here, because what I'm going to do is with that file, I'm going to open that file. Let's call it as F. With that file, I'm going to read through the file completely. So I have this statement. So while this is true, I'm going to read the file. I'm going to read every line. Let me add a counter, add one to the counter. So I'm going to read every line in the file, and I'm going to try to detect every one of those variables. I just want to, I don't want to copy and paste all this in the list and put it back in a list. I just want to automatically, I want to detect all the variables that I have put in there, and then perform what is the next step that I will show you in a bit, which is experimental design. So I'm going to read a line. And in order to read a line, you can use a file.readLine, and this will read a line and then move to the next loop in the while loop every time. And the other thing that we need to do is if there is no line, I want to break this loop. Okay. So at the moment, if I run this, nothing is happening. It's just reading lines and not doing anything. Okay, so if I can read the line and do nothing. But what we really want is to add all the variables here. So if I put, let's say, variables, and I want to be able to somehow detect if there is a variable there. Let me add a function for that, and for that function it will be something like variables inline. This function will receive a line, and this function will give me back what variables are in that line. So let's say, so first I don't want to read the comments. So these lines I don't want to read, because I know that if I put let's put one variable here. Let's say I want to replace a value here, and I put something here, hash whatever. I know that OPM won't read this, because this is the comment style of Eclipse, which is the same comment style in OPM. So I'm going to leave that variable there, whatever, but I don't want to read that line. I don't want to generate, put sensitivities on that particular variable. So just coming back to here. So if that line starts with a comment, I just want to skip. I just want to probably pass. I don't want to do anything. Now, if that line, otherwise, what I would like to do is probably split the line, and I'm going to split it with a space. So what this does is this split. Let's do it here slowly. But let's say I take. I'm going to take one of these lines. Let's say I take this line, and I have it here in Python. Yeah. So we have that line in Python. And if I say that that is my line, I can produce. I can split that line by spaces. Yeah. And let's see what I get back. So I can, now I get this variable, and I get also the name of the fault if I want to use it. But I'm just going to not split. I'm just going to split that line. And the other thing that if once I split that line, for every item here in this list, for let's say item in line, I want to detect if there is a hash. So if there is a hash, I know that there is a variable. So if there is a hash in item, I want to store this variable. And I'm going to put a variable storage here, variable storage here. And what I'm going to do is, or variables, because I don't know if there are many variables in the same line, variables.append. And I'm going to return that item, which will be this item, but I don't want the hashtag. I just want the, for elegance, I just want the name of a variable. Okay, so I'm going to replace that. And this should return variables. So if I run this bit of code, oops, what's happening here? I need to put this in here, and I need the line file read line. Okay, just a second. So if I oh, that's sorry, I see what's going on with the file. Variables equals let me just comment this for a second. So if I want to apply this function to this line, let's see what happens. Variables line. Oops, variables in line, sorry, variables in line. Nothing happened there. Let's see if I put this line here. There you go. So we get the transmissibility, we get that variable back. Now we want to use this function, but I want to go over the whole file and get all the variables in that file. So let's carry on here. And I want to run these variables in line in here. So variables, and I'm going to store these variables. And every time I go through the loop, I want to store everything in all variables. So all variables is equal to all variables plus the new variables that I'm storing here. And so if I do that, let me separate this from the function here. If I run that very quickly, what I'm getting back, I know all of this will make sense what I'm doing all this stuff. It's just to automate the whole process. So you see that I'm getting back all these variables. Now, the only thing that I don't like about this is that it seems that it has not taken into consideration the variables here at the bottom. Oh, I haven't saved the file. Okay, let me save this file. Let me save this file and run it again. There we go. So we have all the variables here. Now, what I would like also to do is to have only one variable, only one name of a variable, because later on I want to replace one variable at a time. I don't need to have repeated name. So one thing that you can do is in here, I can say, well, that all my variables, I can create a set of all the variables. If I return the set of all the variables, you can see that I have just the unique values, or the I don't have a repeated values. I have the values only once. And this is a set. I don't particularly like the set. I'm going to convert this to a list. Okay, there we go. We have a list of objects. Now, yeah, it's a bit of a long process, but what I'm saving time here is that if I eventually want to add, let's say I want to modify one of these variable names, and let's go here into the file, and later on I want to just say, well, I'm going to call this hill. Yeah. So this should, I'm not quite sure if this is pointing to the right data, nor tail. There you go. Yeah. Oh yeah, here it is. Okay. Yeah, unique word for df as well. Yeah. This is just a simple list that we're trying to create here. Now, I don't want to I don't want to create data frames yet here. But now I have that. That is a bit an interesting functionality. And let's say now I want to replace values, and this is where we go into a data frame, and I want to say, well, I want to replace some of those values. So let me delete this bit here, here. And I want to put some sensitivity on this. So first of all, we know that the file name is that one. I'm going to create a function or functionality that replaces values. So let's create here a def, a function that it's, let's say, a file generator. So give me a parameterized file and give me a data frame, and I can take the data frame and replace the variables in the file. That's more or less what we want. So let's write that functionality. So what we would like is that with that file, again, nice functionality, let's open that file. I don't want to write into the file, and I think that I need to just have the right permission to read from the file. And this is a file input. I can call that whatever I want. I put FI in as a file input and not a file that I'm editing. So I want to read the whole file, first of all. So let's say I want to read the whole text, which is equal to the FI in, and instead of reading, here I was using a read line. I'm going to use here read to read the whole file. And what I would like to do is for every item in this data frame, I want to replace the variables in the file. Okay, so for every item in this data frame, I want to replace the variables in the file. So if I have a data frame that it's more or less, let me create quickly a data frame. Something like, let's put some data on this data frame with a dictionary. Let's see if this works. So let's say I want to put 0 transmissibility multiplier to all these false, and also 0 transmissibility multiplier to the different zones within the reservoir. So rather than manually going and creating and replacing this into the file, I want to automatically change those values in the file. Okay. And this is my first input sensitivity. Let's see if that works. Okay. So I'm going to create a df first input, and I want to use pandas for that. So let me add here at the top import libraries. I'm going to import pandas as PD. And now I have here PD dot data frame. And I believe that I can just provide this like that. No? Sorry. This have to be a, I think this have to be a list. Every one of these have to be a list. If I'm not mistaken. There you go. So now I have all those values that I want to replace in the file. Let's say I want to do 2. So I want to replace 0, and I want to run a test which is fully closed, fully open model. Oops. Oh, the first one. There we go. I want to replace those. So I'm going to use that file generator, and let me just jump ahead on this. I'm just going to copy and paste the functionality straight away because we have many more things to do today. What this is going to do here, it's going to read the whole file, and it's going to go through that data frame, which we're going to call df. Okay, it's going to generate a new file. We have to give also the path where we want to generate that file. Okay, and we can also put a prefix to the file. Let's say we want to generate a file that it's called case 1, case 2, case 3, case 4. And the suffix is whether you want to put .data or whatever at the end. So this will create a new file. And with that new file, in write mode, it will replace this whole text this whole text, the new text, and we're going to look for all those variables with the hashtag, and we're going to replace the variables. And this basically iterates over this data frame that I have created here. Okay, so if I run that, so I need to run this file generator. And I have a data frame, which is this one. I need to specify where do I want to run. Let's say I want to run just there in the same path. I want to generate my files. Oh, no, I want to generate my files in the same directory where I have the norm case, which is this one. Because I want to be able to get the include files. So this is a path. And the new file, I want to call it my first sensitivity. And the suffix of the file, it's going to be called just simply data. Okay, so if I run that, oops, let's see if that runs, that works. So if I go into the norm folder, I have now my first sensitivity. So my first sensitivity, what do we have in here? We have a bunch of zeros. Yes, so we replace originally the variables in the parameterized file by these zeros. And in my first sensitivity 1, instead of zeros, we have 1. Is that clear? Now, all of that is great, but what we really want to do with this is come up with a clever way to generate our own scenarios. And of course, I can run that sensitivity file. I can go into Flow. Sorry. I can go into Flow, and let's run that in the background. Meanwhile, this is my first. Where is that? Okay, my first sense 0.data. Let's see if that works. My first sense 0.data. Cannot find input case. I don't know if you see any trouble there. Oh, I forgot to put the .data. Okay, let me delete this stuff. And I'm going to put in the sensitivities .data and run again. So there we have. And now coming back into this. There we go. So now we are able to run that sensitivity. Yeah, thank you, Jico. Yeah. So let's see if that starts running. We can leave it there, see what, oh, yeah. We can leave it there, see what, if it's really going to run or if that causes a trouble, but can leave it there. It's no harm to leave that running, except if I see that my machine is struggling, that maybe I will kill that run.